Hello, Algebra 2 students. I am going to I'm making a Unit 7 review for all things in Unit 7. So this could be used for any quiz in Unit 7, for the Unit 7 test. There's not actually a written Unit 7 review in your online learning system. It looks like there is, but I think it just tells you to review. So I think this is the only unit where you don't have a bonus for the Unit 7 review. I'm going to go ahead and talk about some announcements really quick. We have a lot of things coming up after Thanksgiving break. The honors project is due on Monday, December the 2nd. And then we move on to finish Unit 7 the week after Thanksgiving. TGAs are going to be due December the 11th. CGAs are due December the 13th. Exemptions will go out by email on December the 16th. And your math final exam will be December the 18th. That is if you are not exempt. There'll be more information about your math exam. You'll be given a semester exam review. The week before exams, we'll go on a modified schedule and we'll go over those exam reviews. Just a quick reminder, to be exempt from each class, you have to have a 90 or above. Number one. Number two, no incompletes on required assignments. You definitely can have zeros on bonuses, but you can't have incompletes on required assignments. No zeros on required assignments. And number three, you must have taken the STAR reading in math at the beginning of the year, or if you're a new student, you had to take it when you enrolled. And then number four, for that specific class, you can't have any disciplinary actions. Today we're just reviewing Unit 7. This is a video, so I am going to skip the your choice and jump ahead. I am talking pretty fast. Y'all can stop, rewind, play again. My recorder that I use only records 30 minutes at a time. So number one says, what is the degree form for 5 pi over 4? So you can use your unit circle for this. You would just Google unit circle, or you could use a whiteboard deck that you've saved that I've used in class. So 5 pi over 4, and they just want the degree. So I got to find 5 pi over 4 on the unit circle. It is located here, and it matches with 225 degrees. So that's just a conversion problem from radians, and most of the time you're going to know an angle is in radians because it has pi in it. Like 99% of the time it's going to have the symbol pi in it, and you're going to know that's radians and not degrees. But don't assume you have degrees unless they actually give you the symbol for degrees. All right, problem number 2, it says, what is the positive coterminal angle to negative 32? And that positive angle must lie between 500 and 1,000. And then what is the negative coterminal angle of negative 32? Again, and then that negative angle must lie between negative 500 and negative 50. So let's start with the positive. So let's start with the number 1 question. So they're giving us negative 32. And they want a positive angle between 500 and 1,000. So to make your number larger, you're going to add 360 if you're given degrees. If you're given radians, you're going to add 2 pi. So remember that 360 degrees is all the way around the circle, and that's also equal to 2 pi, which is all the way around the circle. So if you're given an angle in degrees and you're trying to make it larger, you're going to add 360. If you're given an angle in radians and you're trying to make it larger, then you're going to add 2 pi. Okay? So if we do negative 32 plus 360, let's see where that gets us. That's going to get us to 328. And we're trying to be between 500 and 1,000, so that's not big enough. So I'm going to add 360 again. That's just adding a total revolution. It's going to get you back at the same spot. You're just going to have to figure out how many times you have to add 360. That's going to give me 688 degrees, which does lie between 500 and 1,000. So that's going to be my answer for number 1, 688, and then degrees is already in that box. On the second problem, where they're asking you for an angle, same angle. So on the second problem, we're looking for a negative angle, and we are still starting with negative 32 degrees. And this angle has to be between negative 500 and negative 50. So if you're trying to make your angle smaller and you have degrees, you're going to subtract 360. If you're trying to make your angle smaller and you're in radians, then you're going to subtract 2 pi because those are both 1 revolution. So I'm going to subtract 360. So negative 32 minus 360. Let's see where that gets us. That gets us to negative 392. We're supposed to be between negative 500 and negative 50, and we are. So we can stop there with negative 392 degrees. So let me double check this. I got 688 for the first answer. Check. Negative 392 for the second answer. Problem number 3. In which quadrant does the terminal side of the angle 260 degrees lie? So I am a visual person, so I would draw my x-axis and my y-axis, and then this would make a circle. My circle's not very good. So remember, quadrants are starting in the top right with Roman number 1, and then we travel counterclockwise, and we number everything else. So if I'm going 260, so this is what my brain does. So remember, you always start on the positive x-axis, always right here, and then when we rotate a positive angle, we rotate counterclockwise. So this would be 90 degrees, this would be 180, this would be 270, but we're not going to 270, we're just going to 260. So this rotation would represent 260, and that's going to put us in quadrant 3. If we rotated between 0 and 90, we would be in quadrant 1. If we rotated between 90 and 180, quadrant 3. Between 90 and 270, between 90 and 180, quadrant 2. Between 90 and 270, goodness gracious, rewind, let me start again. If your angle is between 0 and 90, you're in quadrant 1. If your angle is between 90 and 180, slow down, Ms. Prater. Your angle's in quadrant 2. If your angle is between 180 and 270, your angle's in quadrant 3. If your angle is in between 270 and 360, then you're in quadrant 4. Blah, blah, blah. If you're at 0 degrees, or at 90 degrees, or at 180 degrees, or at 270 degrees, you're not actually in a quadrant. Those are called, I never can say it, quadrantal angles. So if you're exactly at 90, 180, 270, or 0, or 360, you're not in a quadrant. It's like being on an axis. Okay. Number 4, a circle has an arc of 32 pi that is intercepted by a central angle of 240. So again, you don't have to draw this. This is just me, just being me. It just helps me to draw it. So again, this would be 180. And, if we went all the way to here, that would be 270. So I'm just going to kind of go almost leave 30 degrees there. So we're talking about this angle. And we're talking about the arc. So the arc would be this part of the circle. So the arc is 32 pi. There's a couple different ways to do this. Students kind of see this differently sometimes than I do. So if you find an easier way, go for it. Okay. But it wants to know the radius. So we're looking for the radius. Big question. What is the radius? So they want to know this distance, which would be the same as this distance. I know my circle is totally not circular, but they want to know the distance from the center to the outside, which should be the same on this side also. I just have a crummy circle. All right, so what did I do on this problem? I started with 240. So this is just where my brain went. There's a couple different ways that you can work this. So 240 is out of a total, all the way around the circle would be 360 degrees. I divided both sides by 10. That gave me 24 over 36. You could also put this in a calculator and reduce it. Let's see, 4 goes into 24 6 times. 4 goes into 36 9 times. That'll reduce again by 3. 3 goes into 6 2 times. 3 goes into 9 3 times. So this arc, this little section cut off by 240 degrees is 32 pi, and it represents 2/3 of the circumference. It represents 2/3 of all the way around, and we call that the circumference. So then what did I do? I looked at I took 2/3 and I said that is 32 pi out of the entire circumference. So in order to find the radius, you're going to have to find the circumference. So this is just how my mind worked. Again, you might do this a little bit different. The only variable that I have to solve for is c, so I'm going to cross multiply. That's going to give me 2c is equal to 3 times 32 is not 6. 3 times 32 is 96 pi? Let me think about that for a minute. It's 8:35 in the morning. 3 times 32 is 96. Still solving for circumference. Divide both sides by c, and the circumference is going to come out to be, what's 96 divided by 2? 38? No, 48. 48 pi. Now, if the circumference is 48 pi, let me bring you up here. The formula for circumference is 2 pi r. If I know the circumference is 48 pi, then the only variable left in my formula would be the r, and that's what I'm trying to solve for. So I would divide by 2 pi. Don't let the pi scare you. You have a pi on both sides, so they're going to end up canceling each other out, and the radius is going to come out to be 24. There might be an easier way to do this one, so definitely if your brain thought about it in a less complicated way, go for it with that. Sometimes I don't always think about the shortest way because I have a lot of math in my head just because I've been teaching school for 33 years. So sometimes the math takes over the common sense part, and sometimes that just happens. It is what it is. All right, answer to that one is the radius has to be 24. Number 5 says a circle has a radius of 96. So this time they're telling us the radius is 96 centimeters, so we're definitely not looking for the radius. But it does look like we're looking for the length of the arc that is intercepted by a central angle of 2 pi 9 radians. Express your answer in terms of pi. So what are we looking for? We're looking for the length of the arc. Sometimes I get caught up in the problem and I don't even know what I'm looking for. So sometimes I jot that down just to help me figure out what's going on. So what did I do on this one? So we know, so I thought about a circle and I rotated 2 pi over 9. So 2 pi over 9, this is 0. Let's go to radians. Let's just talk about this for a minute. 90 degrees is pi over 2, 180 degrees is pi, 270 degrees is 3 pi over 2, and then if we go all the way back around, this is 2 pi. So this could be 0 radians or 2 pi radians. So 2/9, so this is 1/2 pi, and 2/9 is actually smaller than 1/2. So if you thought about 1/2 in terms of nines, 2 times 4.5 is 9, 1. So 4.5 over 9 is 90 degrees. So that's 2/9. So we know that 2 pi over 9 is small. So it's like this little bit. So 2 pi over 9 is the measure of the angle. So this angle is, let me draw a little arrow because I don't have enough room. The angle is 2 pi over 9 radians. So instead of giving you degrees, they gave you radians. So if they would have said 30 degrees, that would have made more sense to you. So we had to kind of break that down and think about what 2 pi over 9 radians is. So the question is, what is this arc length right here? What's the distance right here? So remember, arc length is part of the circumference. Arc length is part of the circumference, and they gave us the radius. So let's think about this for a minute. The radius is 96 centimeters. That means the circumference would be 2 pi times the radius, which means the circumference would be 2 pi times 96, and the circumference would be, what is 2 times 96? 192? 192 pi. So it's telling you leave pi in there. Don't turn that into 3.14. So that's the circumference. So what I did is I found out what part of the circumference. So 2 pi over 9 out of all the way around, which is 2 pi. And so then that's 2 pi over 9 divided by 2 pi, which is really 2 pi over 9, times, flip this fraction, 1 over 2 pi. Cancel out your 2 pi's. So that little angle is 1/9. It's just 1/9 of the whole circle. And then I just multiplied 1/9 times 192 over pi. So it's 1 times 192, that's 192. 9 times 1 is 9. And then I don't think this is reduced. So 192 divided by 9 is 21. 21 times 9 is 189. And that's 3 left over. So that's 3/9 or 1/3 pi. You could write it as 21 and 1/3, that's a mixed number, or you could do 3 times 21, which is 63 plus 1. You might see it as 64/3 over pi. Those are the same answers. I thought that one was pretty hard. All right, number 6. A point on the unit circle has a terminal side of an angle in standard form and is in position in quadrant 3. So let's find quadrant 3. This is 1, this is 2, this is 3. So in quadrant 3, x is negative because you got to move to the left to get to quadrant 3, and y is negative because you got to go down. So that's important. It says select the drop-down box menu to complete each statement. A point on the unit circle lies on the terminal side of an angle in standard form. Cosine is always your x value. Sine is always your y value. So this one is just negative for the x. Your cosine value is your x value. So your x value would be negative in the third quadrant. Your sine value is your y value. Your y value would be negative. If you were in the second quadrant, your x value would be negative because you're going left, and your y value would be positive. If you were in the first quadrant, your x and your y would be positive because you're moving to the right and up. If you're in quadrant 4, then your x would be positive because you got to move to the right to get to quadrant 4, and your y would be negative. So this is all based on the quadrant that they're giving you. Number 7. What is the exact value of the trig function sine? So sine is important. So sine, you know you're looking for the y value at that ordered pair at the angle of rotation 20 pi over 3. So if we take a look, we're not going to find 20 pi over 3 on the unit circle. So that probably means that it's bigger than 2 pi. So let's take 20 pi over 3 and let's break it down. So let's think about it as being 20 over 3 times pi. 3 goes into 20 6 times, that's 18, and 2 is left over. So yeah, that's 2 pi, 4 pi, 6 pi, I feel like I'm doing a cheer, and 2 pi over 3. So it's actually right here. So you can do it that way and know that it's 2 pi over 3. If that confuses you, then you can subtract 2 pi's until you get a number between 0 and 2 pi, which would be on the unit circle. So again, I shouldn't have circled 2 pi over 3 because that's not my final answer. It's going to help me find my final answer. But you could actually think about this as rotating. Again, 2 pi, 4 pi, 6 pi, and then 2/3 pi, and that would put you right here. You could do it that way. Okay, or you could keep subtracting 2 pi until you get an angle between 0 and 2 pi. So this is where you're going to end up with 2/3 pi, which is the same as 2 pi over 3. And then they're wanting sine, so they're wanting to know the y value. X is cosine, y is sine. So your final answer here is square root of 2 over 2. So this one was just trickier because they didn't straight up give you an angle on the unit circle. They gave you an angle that was bigger than 2 pi, and you had to figure out that that was the same as 2 pi over 3. Number 8, what is the exact value of the trigonometric expression in simplest form? I always thought that when you look at this problem, this looks absolutely horrible. But all you're going to do is you're going to do 2 times, and you're going to find this value on the unit circle. So we go find 3 pi over 4, which is here. It's asking for cosine, so that's your x value. So that's negative square root of 2 over 2. So we're going to multiply 2 times cosine of 3 pi over 4, which is negative square root of 2 over 2. We can make it look a little bit better and do this. Minus 4 times sine 7 pi over 6. So let's find 7 pi over 6. Where are you, 7 pi over 6? 7 pi over 6, you're right here. And that is sine, so that's the y value, which is negative 1/2. We have to multiply before we can subtract. So the 2's are going to cancel, and I'm going to end up with negative square root of 2. 4 times negative 1/2 is negative 2, and then don't forget you're subtracting. So this negative square root of 2 is going to come down. When you subtract a negative 2, that's going to make it a positive 2. You can't add a 2 with a square root of 2 because those are considered unlike terms. So this would actually be your final answer. You might also see it with a 2 written first and then the minus square root of 2. That means the same thing. Number 9, theta is in quadrant 1 and the sine of theta is 5 over 6. So let me remind you that sine is r over y. I'll write all these down. Cosine, if they gave you cosine, that's, I did that wrong. Cosine is x over the radius. Sine is y over the radius. And tangent is y over x. So what happens is we're getting deeper into unit 7 when we don't have a unit circle. So if we had a unit circle, the radius would always be 1. And so x divided by 1, that's why we say cosine is always x. Y divided by 1 would be y. That's why we always say sine is y, 1. And then y divided by x is y divided by x, no matter whether you're on a unit circle or not. So, but once you get into the latter part of unit 7, we start looking at circles that have radiuses that are not 1. So sometimes the radius of the circle might be less than 1, sometimes the radius of the circle might be greater than 1. Then we can't always use our unit circle. So these were the formulas that we got when we were looking at circles that were not unit circles. So they are telling me we're in quadrant 1. Why is that important? Because if I'm in quadrant 1, we always know that x is positive and y is positive. So if they give us sine, so let's think about this for a second. If they give us sine as 5 over 6, we can take our formula, and we know that sine is y over r. So that's telling us that our y is equal to 5, and our r is equal to 6. They're asking us to find cosine. Well, to find cosine, we have to know x. So before we can answer their question, we have to find x. Well, we have a formula, which is actually the Pythagorean theorem. And it says our x squared plus our y squared is always equal to our r squared. So we don't know our x, so we'll leave that as x squared. We do know our y is 5. So 5 squared equals our radius squared, which is 6 squared. So we're trying to find our x so we can figure out what cosine of theta is. So our x squared plus 25 is going to equal 36. We're going to subtract 25 from both sides. That's going to give us x squared equals 11. We'll take the square root of both sides, and that's going to give us x equals the square root of 11. So then we can find the cosine of theta, which is going to be x over r. So let's put rx right here, since we just found it. Our x is the square root of 11. So our cosine is going to be square root of 11x over the radius 6. And then that would be your final answer. Number 10, the terminal side of theta, which is just a variable for an angle, passes through the point x negative 8, negative 7, my bad. I'm thinking 8 is my x, negative 7 is my y. What is the exact value of cosine? So again, we know our x is 8. We know our y is negative 7. Cosine is x over the radius, and we don't know the radius. So we got to find the radius. So we're going to use that Pythagorean theorem again. X squared plus y squared equals r squared. That's 8 squared plus negative 7 squared equals r squared. And by the way, your radius is always positive. Your x and your y could be positive or negative, but your radius is always positive. 64 plus 49 is 113, I think. Take the square root of both sides, don't forget this part, and the radius is the square root of 113. Go back to your formula. Your x is 8, your radius is the square root of 113. Your OLS might take this answer, so I'm just going to kind of not circle this, but I know that the best answer would be to get rid of the radical in the bottom. So we would multiply the top and the bottom by the square root of 13, and that would give us 8 times the square root of 113, excuse me. Multiply the top and the bottom by the square root of 113, and then square root of 113 times square root of 113 is just 113. That gets rid of the square root in the denominator, and that would be our final answer. All right, we got 2 more. Number 11 says enter the value of arc sine of 0.73. So because they don't put a percent sign, Lord help me, because they don't put a degree sign, you have to assume that this is radians. Okay, so you're going to straight up in your calculator, this is a straight up calculator problem, you're going to make sure that you're in radians. So how do you do that? So let me pull up my calculator. Here's my Desmos Scientific Calculator I got for free. So on the Desmos Scientific Calculator, here's your radian. You got to toggle to radians if you put the angle in radians. You got to toggle to degrees if you put the angle in degrees. So whatever calculator that you're using, you got to be able to go back and forth. So I'm going to hit radians here. I got to figure out how to do second. On a regular calculator, you would make sure that you're in radians, and you would do second because it's arc sine. So that means you're finding the angle that has this sine value. So you have to do second sine, and then you put in the 0.73 as long as you've told your calculator that you're in radians, and then you're going to get the answer. Right now, on the second, at this moment, I don't know where the second, oh, here it is. You have to go to functions. This sine to the -1 means the inverse of sine. So we'll do sine to the -1. Oops, you don't want to see that. Let's see. 0.73. 0.73, close parentheses. And that's going to give me 0.818321. And I forgot how they said to round to the hundredth. So that's 2 places. So that's going to be 0.81. And then that 8 is going to round the 1 up to a 2. So 0.82. On my TI-30X, I actually have a blue second button. And so I have to hit that blue second button, and then I have to hit sign. And that's when it pops up like this on my calculator to the -1. That's the same as arc sine. All right, I think 12 is the last one. This one says, what is the exact value of arc sine of -1/2? So sine is y. So you're looking for where your y is -1/2. Not there. That's an x. So if the y is -1/2, it could either be here or here. Those are the only y values in all the unit circle ordered pairs that are -1/2. But we do have some restrictions. It says if we're doing arc sine and arc tan, and we're doing arc sine here, we are restricted to only answer in the first quadrant or the fourth quadrant. If you were doing arc cosine, then you would only be able to answer in quadrant 1 and quadrant 2. It's because there's 2 answers, and they're giving you a restriction so you know which one to look for. So it's not going to be this one because that's in quadrant 3. We're doing arc sine, so we have to either be in quadrant 1 or quadrant 4, and that puts us at 11 pi over 6. Because it wants radians, then that's how you know you don't answer 330 degrees, you answer 11 pi over 6. That's the same angle as 330 degrees, but it's radians. All right, guys, I know that was quick talking. Again, you can stop, rewind. I just have 30 minutes when I do videos, so I wanted to get this out to you. Remember, this is a review for Unit 7. This will help with any quiz in Unit 7 and Unit 7 test, or to study for the semester exam. Hopefully this was helpful. If you have any questions, let me know.